This is the continuation of our discussion. So we are now in parallel and series parallel circuit. So number 1, a unity power factor load of 1794 watts is connected in parallel with a load of 1656 watts operating at a lagging power factor of 0.6. If the line voltage is 115, calculate A, the current in each load, the total current, the total power, and the overall power factor, and also the reactive volt ampere. So we will list all the given. We have two loads connected in parallel. Let's say the first load is P1, that is equal to 1794 watts. And it has a power factor of unity, PF1. Load 2, P2 is equal to 1656 watts, power factor of 0.6 lagging. And our line voltage or the source voltage is equal to 115 volts. So we are going to calculate the current in each load. So for load 1, I1, load 2, I2, and also the total current, IT, the total power, PT, and the overall power factor, let's say PF, and the reactive volt ampere or Q. So let's draw the circuit diagram of this problem. Let's say this is our load 1 and load 2 connected in parallel. This is our source. This is P1, P2, I1, I2, and total current. So from here, we can say that your total current is the sum, vectorially sum of I1 plus I2. And also, total power, we can solve total power equal to total voltage, total current, cosine theta. Since cosine total power factor is unknown, we can solve also total power is equal to P1 plus P2. Kasi unknown yung cosine theta, this one, D, overall power factor. We can now solve for I1. From our general formula, P is equal to this one. P is equal to E I cosine theta. Given yung power factor, given yung voltage, given yung power, so we can solve I1 equal to P divided by E cosine theta. So power is 1794 divided by 115. In parallel, diba, the voltage here is the same as the source voltage, and also the voltage here at this branch is the same as the source voltage. 115. Cosine theta is unity, so that is 1. I1 will be equal to 1794 divided by 115. 15.6 amperes. So that is angle 0 because it is unity or they are in phase with the voltage. Next, I2 is equal to P2. This is P1. P2 divided by E cosine theta 2. P2 is 1656 divided by 115 times 0.6. 656 24 amperes angle. So arc cosine of 0.6 is 53.13. Lagging power factor, so this is negative 53.13. It means that it has an inductive load because the power factor is lagging. We already solved I1 and I2. So masasolve na natin yung total current. That is 15.6 angle 0 plus 24 angle negative 53.13 equal now to 35.618 angle negative 32.62 degrees ampere. If we are going to draw the vector diagram of I1, I2, and IT as well as the voltage, so it will look like this. The voltage is in phase with the reference. Also I1 kasi angle 0 siya. And then our I2 lags the voltage by 53.13. This one. And then solving now the total current, 35.618 angle negative 32.62. So the angle between the current and voltage will be this one, theta t, which is equal to negative 32.62, or negative means it has a lagging power factor. So there are two ways also. You can see here that this is already the power factor, total power factor, and also we can verify that using cosine theta t is equal to power factor equal to total power divided by the total voltage times the total current equal to 3,450 divided by 115 times 35.618, that is 0.842 lagging. So as we can see here, if we get the arc cosine of 842, it is equal to 32.649. This is now the total power factor, 0.842 lagging. So always give the direction of your power factor, which is lagging. Solving now the volt ampere, reactive volt ampere Q, that is EI sine theta. So 115 times 35.618 sine of theta, which is 32.649. That is equal to 2,209.793 var or 2.21 kvar. Number 2, calculate the equivalent impedance of a circuit in which a coil of wire having a value of 5 angle 53.2 degrees ohms is connected parallel with a capacitive reactance of 6.25 ohms. So this is our impedance 1, 5 angle 53.2 degrees ohms, and our impedance 2, since this is a capacitive reactance, magiging negative yung J component mo. So that is negative J 6.25 ohms. Solving for the parallel combination of these two impedances, we have total impedance is equal to Z1, Z2 divided by Z1 plus Z2. So it will become 8.347 angle 0.07 degrees ohms. Next one is determine the current drawn by the following circuit in this figure when a voltage of 200 volts is applied across the same. Draw the phasor diagram. So we have impedance 1, 4 plus J6, since this is an inductive X1. Z2 is 10 minus J12. Z3 is 6 plus J10. So, before natin ma-solve yung total current, kailangan muna natin isolve yung total impedance. So, total impedance is Z1 plus this one, the parallel combination of Z2 and Z3. Okay? So, Z23, solve muna natin tong part na to, Z23. So, that is 10 minus J12 times 6 plus J10 divided by 10 minus J12 plus 6 plus J10. So that is equal to 10.862 plus J 3.108 ohms. After getting the parallel combination of these two, we will add now your impedance 1. So, impedance 1, 2, 3 or the total impedance is equal to Z1 plus Z23. Inad ko lang tong 10.862 plus 3 J 3.108 to 4 plus J6. So, it will become 14.862 plus J 9.108 ohms. From your Ohm's law, we can solve total current is equal to total voltage divided by total impedance. Total voltage is 200 angle 0 divided by 14.862 plus J 9.108. That is 11.474 angle negative 31.502. As you can see, negative. So, your current, total current, lags the voltage by negative 31.502 degrees. So, the current flowing in Z1 here is equal to I. It is equal to your total current here. So, we can solve I2 and I3 by your current divider theorem, which was discussed to you in your circuits 1. So, same principle. Solving for I2 is equal to the total current multiplied by the impedance, parallel impedance of Z23 divided by Z2. Ito. So, may isa pang formula dito, pero mas gusto ko tong gamitin. Yung isang formula is IT multiplied by total impedance divided by Z2 plus total impedance. Pero mas comfortable ako dito. So, IT multiplied by Z23 divided by Z2 and I3 is total current times Z23 divided by Z3. So, 11.474 angle negative 31.502 times 10.862 plus J 3.108 divided by impedance 2 is 10 minus J12. So, your total current will be 8.299 angle 34.866 degrees ampere. Yung I3 naman, you can solve this one using KCL at node B. Because we already solved your total current, and your I2. So, mag-KCL ka lang dito. So, I3 is equal to total current minus I2. Or you can use the CDT. So, I3 is equal to 11.474 angle negative 31.502 times 10.862 plus J 3.108 divided by 6 plus J10. That is equal to 11.116 angle negative 74.571. Or, using KCL, equal to I3 is equal to IT minus I2. So you can recheck this one using KCL.